Our project discusses data storage. Data comes in all shapes and sizes, but they are all represented on modern storage media using the binary numeral system. Each number of binary digits represents a character that is translated by the computer to text. Data is converted to a string of bytes known as binary digits, with values of 1 or 0. External storage as USBs, SD cards. Internal storage as RAM, SSDs. Traditional data storage methods. Year 1949 at MIT, J. Forster develops the baseline for the magnetic core memory system. It was the first reliable high-speed RAM. IBM introduces again a computer system that dawned the magnetic disk storage system. The RAM AC disk drive, the first hard disk drive, it was capable of storing about 5 million characters of data. NCR CRAM consisted of Mylar magnetic cards. Each card was made up of 7 data recording tracks that could be individually addressed of reading or recording a data. IBM 1360 digital storage system, the first such system in the world, which 5 only were made due to its sophisticated error correction and its high maintenance.
Let's now move on to the limitations of traditional data storage. There is a lot of issues facing data storage nowadays. To begin with, we have infrastructure. The need to store data grows as data grows. It needs to become more software-driven than hardware-driven. In addition, we have cost. The cost of local storage keeps on increasing over time, and you need to take in consideration a lot of things. The cost of hardware, power consumption, and physical space needed to implement on-premise storage. Also, it needs high maintenance, since that systems must be upgraded to ensure optimal performance and reliability, and the upgrade cost may vary each year. Moreover, we have flexibility of accessing data. This requires a lot of maintenance and regulatory checkups. At times, it becomes difficult to view data fast or even retrieve a lost batch. Moving on to new ways to store data, we have NBS, which is a network-based storage system. Multiple systems can access it at the same time, meaning it makes sharing and collaborating with others more easy. There are two common NBS setups, which are NAS and SAN. NAS is a single device comprising a RAID, which is the redundant array of independent disks, and it's based on file storage system, while SAN is a network of a combination of devices like SSD, USB, flash memory, cloud storage, and a lot more. Cloud-based storage is a magnified form of NBS, as it uses the internet instead of depending on the local area network to support the storage of data. Cloud storage is quite like its name, meaning that data is being stored on virtual or cloud servers hosted by third parties. It provides easy accessibility at any time over the internet, and it also offers great storage for minimal costs. For example, Google Drive, iDrive, Amazon S3, IBM Cloud Object Storage, iDrive, and Blackblaze.
Moving to the future of data storage. Scientists have searched for years for a reliable way to store data in a way which it cannot be lost whatever happens. But all along the answer was in ourselves, literally inside us, which is DNA. They thought that it already stores our biological information, so that's a string we can hold up to. It consists of 4 bases: adenine, guanine, cytosine, and thymine. A specific sequence of these bases into groups of 3 is known as codons, which is simply the programming language of our bodies, but we can use it to program other things too. With a possible 64 DNA codons, they succeeded to create an alphabet. In 2016, researchers at Microsoft and the University of Washington we're able to capture 200 megabytes of data into strings of DNA. DNA has a half-life of 500 years, which is larger than any other storing system we have known till now. While aiming to reach our maximum human potential, Project Silica was born. Project Silica was proposed by Microsoft, exploring the possibility of quartz glass to store data in the cloud for long periods of time, due to its great durability. In 2013, they succeeded to store a 300 kilobyte text file in fused silica glass by etching a nanoscale gratings at various depths and angles, creating a 3D gratings layout of the data. A special type of microscope is used to read the data. Now, new studies have shown that we can store data on a single atom. Scientists already made progress in storing bits on atoms on a very small scale and in under extremely cold setups. Recently, researchers at Radboud University have made new developments in order for this new innovation to work under room temperature. But it might be a while before this setup can be used in everyday technology due to its complicated nature. So, that was our presentation. Thank you for listening.